Hello everyone again. So in this recording I will talk about the motion of a projectile. The motion of a projectile is like we can say like a rocket that it moves. So we have a parabolic motion. So this one is a parabolic motion. And then for this one we assume that there is no resistance in x direction. So in other words we say that the drag force is negligible. And then the acceleration in y direction is only g, so that body experiences the gravitational acceleration only, and the formulas that you will use for x direction is the velocity that doesn't change because there is no friction force or acceleration in x direction. Therefore the position in x direction will be the initial position plus the velocity in the time. In y direction, we have the y velocity minus the gravitational acceleration to time, and then position, and then we have the change of velocity with respect to initial velocity. But this third one, it is not independent. Actually, you can get the third one by combining these two equations. From these equations, you can get the third equation. Okay, these are the equations that we are going to use. I will not derive the equations as I told, so I will just use it in the examples and you can see how do we apply it. But the derivations are very easy. So they are all just application of that is V is ds by dt and the A is dv by dt. And all of them are coming from the integration of these two formulas. And then motion of a projectile we can analyze this way. Say that this is the initial point where the particle starts its journey, and then you can always look for say that this is the velocity. So velocity at, say that t, and then for this velocity you can look for the x component, and then you can look for the y component. Similarly, if you go here, say that this is the velocity, and then for this velocity you will have the y component. Let me write in a different color. And then you will have the y component, and then you will have the x component, and then similarly here and similarly here. And as I said, the Vx is constant. It does not change. This is very important. And also you will have the x direction, so x distance, and then you will have the y distance. And the time for y distance and x distance is the same. So let me give you just one simple example. Yes, say that this is point A. Let me use different color. This is point A, and then this is point B. So it takes, say that, 10 seconds to reach from A to B. Okay, that 10 seconds is the set time required to travel this much. The same time that is required for this much, it is the same time required for this much. So this three of them happens at the same time. I mean, it looks like they are independent, but they are not independent. Okay, so what it means is that these 10 seconds spent for, let's say that this y distance, I will call it as AB y, and this x distance, I will call it as AB x, and then this path, I will call it as SAB. The 10 seconds is spent for ABY or ABX or SAB. The same time. So I'm trying to tell you that. So these three components, three of them, are not independent. So we are just separating them to solve the problem easily. That's the very important point here. So I will solve a new problem in the next recording.